Blend BM25, embeddings, and business signals into one production ranking system with Vespa. This is the workflow you'll know how to run when we're done, which stages documents and ranks results by blending text match, embeddings, and business signals. I'm Professor Pi, teaching search and IR with simple Python. Search teams face a common problem. Text match finds exact words. Embeddings find related meanings. Business signals push revenue or freshness. Combining them well is the hard part. Vespa rank profiles give you a place to express that blend and run it at serving time. Success means relevant top results, consistent latency, and a simple knob to tune trade-offs. For many sites, this improves click rate without rewriting the whole stack. The core idea is intuitive. Stage a wide candidate set, then re-rank with a profile that mixes BM25 style scores, vector closeness, and business features. Imagine a query that matches text and also relates semantically to some items. We want to return both, but order them by what matters for business. Vespa lets you do that inside the serving engine. We will build a tiny baseline you can run locally. It will show 3 searches: text only, vector only, and a hybrid that blends clicks with semantic closeness, finishing with a 2-phase re-rank. That makes the difference between a prototype and a production baseline. Now we'll run a simple BM25 check. This snippet connects to a local Vespa instance and executes a simple BM25 style keyword search. The Vespa client, stored in the variable app, points to the running endpoint and is used to submit a query via app query. Well, YQL string selects all fields while the user query function matches the query text against the schema's indexed fields. The result object contains hits, and the variable hit references the first item, so we can extract its relevance score. The variable S rounds that score for clearer on-screen reading. If you increase hits, Vespa returns more candidates, which can raise latency slightly. The printed score confirms the top document under text-only ranking. Next, we will test vector retrieval to see semantic matches. This example performs an ANN retrieval on Vespa by injecting a query embedding and using the nearestNeighbor operator. The variable QV holds the query vector and is passed as a query feature using the key ranking.features.query. The YQL clause requests candidates via approximate ANN with target hits set to 3, which influences both recall and latency. The app.query call returns results where relevance reflects vector closeness under the active profile. The variable H captures the top hit so we can access its ID and relevance for printing. Increasing target hits generally improves recall at the cost of more work, while decreasing it speeds queries. The printed score shows the vector-only match strength. Now, we will compare the 2 signals directly. This code contrasts text relevance and embedding relevance for the same intent. The variable B is the top BM25 style hit for the query phrase, requested via app query with user query in YQL. The variable H is reused from the previous ANN call and represents the top vector match. We extract scores into SB and SA and compute which approach wins using a simple comparison. The printed delta shows how far apart the winners are, giving a quick signal of disagreement between lexical and semantic retrieval. Tuning the query text or embedding can flip the winner. The printed comparison highlights which signal currently dominates for this query. Next, we will blend them with a business signal. This snippet runs a hybrid retrieval on Vespa that unions text and ANN candidates, then applies a custom rank profile. The YQL clause uses user query for BM25 style matches and nearestNeighbor for vector candidates, giving a wider recall set. The ranking.profile hybrid business is expected to combine BM25 and embedding scores while also accepting business features. The query feature wclicks is a tunable weight that promotes popular items, while QV supplies the query vector. Increasing wclicks favors frequently clicked items. Reducing it emphasizes pure textual and semantic relevance. The printed top result reflects a blended score that accounts for content and business preference. Finally, we will enable a two-phase rerank to mimic production. This example builds a small production baseline by enabling two-phase ranking with a hybrid profile in Vespa. The YQL unions BM25 and ANN candidates with a larger target hits to improve recall. The ranking.rerankCount parameter asks Vespa to apply the more expensive final ranking to the top subset, improving ordering where it matters most. The variable QV remains the query vector, and wclicks continues to express business preference. Increasing rerankCount can boost quality but costs more CPU. Lowering it reduces latency at potential relevance loss. The printed top document and relevance confirm a blended, re-ranked result suitable for serving traffic. In a real deployment, you map these pieces to your pipeline. Candidate generation runs in the first pass. Store embeddings and click features in your document feed. Use a small re-rank count at first and measure latency and click rate before expanding. This pattern scales. ANN for vector lookup, BM25 for lexical precision, and a rank profile that ties in signals. Recap. What it is: a serving time rank profile that mixes BM25, embeddings, and business features. When to use it: when you need semantic matches plus business-aware ordering at serving latency. One caveat: blend weights and re-rank size change both relevance and cost. Next step: tune the re-rank count and the business weight to find the latency quality sweet spot for your traffic. If short practical IR helps, subscribe and watch the IR videos.